Put the new thing in there. Hey, what's up, everybody? Welcome back to another 3D Hangout, episode 186, Drone Claws and Paper Boxes.
That's right, this week we're going to be taking a look at a CircuitPlayground powered drone claw.
We're going to look at some paper boxes. All this and more on, you guessed it,
3D Hangouts.
Excellent.
I love audio things. Hey, what's up, everybody? Welcome back to another 3D Hangouts. My name is Noah Wes. I'm a designer here at Adafruit, and joining me every week is Mr. Pedro.
What's going on, everybody? I'm Pedro, creative tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing DIY electronics to make inspirational projects for you, the listener, the watcher, the person, the maker. Welcome so much. Welcome. Thank you so much for joining us today. It is early. We do this show every Wednesday at 11 a.m. in the morning. It's morning over here. Pedro's drinking coffee. So that's what we're gonna do today.
Start off with paying some bills. This week's coupon code is LightPipe. LightPipe will get you 10% off your Adafruit order. Works on everything except certificates and subscriptions. It's good until 11:59 p.m. tonight.
That's right.
So got a couple of freebies going on. You can check out all of them at adafruit.com/free. Take a look at all the different tiers we got.
Yeah, some great stuff. Check it out. We're still having it while supplies last. Same day delivery for fine folks in New York City. So check that out if you want to do the same day delivery. There's certain zip codes and stuff, so check it out at the website. We have a CircuitPython meeting every Monday at 2 p.m. If you want to join, you can do so by heading over to the Discord channel, discord.gg/Adafruit. That's where you can get it for the invite link. We have some newsletters. We have the daily Adafruit newsletter. Go to adafruitdaily.com to opt into that. We got some new subscribers. Thank you guys for subscribing. You, of course, have to opt into this one. We also have adafruit.com/newsletter. You get a product focus. This is once a week, not every day, just once a week. Product focused and some news and things like that. This, was it yesterday? We had the Cricut sneak peek, which was really great.
Nice little sneak peek at that.
All right, hanging out in the Discord server. If you guys want to say hello after the show, we'll be there. So check out discord.gg/Adafruit.
That's right, we're hanging out in the live broadcasting channel right now, but later on we'll be in the 3D printing channel. Of course, we'll stop by all the other ones like the off-topic, but there is a ton of channels in there if you guys want to get any assistance with any projects that you're working on. We have a ton of those there, and that's actually where we have the CircuitPython meeting. If you scroll all the way down on the left column where all of the channels are listed, scroll all the way down to voice, and we'll have the CircuitPython channel inside there where everybody can chime in during the show.
That's right. And here we are, live broadcast. Sweet.
Go ahead and jump into this week's flying project video. We've been talking about it for about a month. This week's project is the CircuitPlayground powered drone claw for the DJI Mavic Pro. So here's what it looks like, all assembled. So the cool hack about this is that we're actually using the LEDs from the Mavic Pro light pipe that's going right into the CircuitPlayground Express. Sorry if you can't see it there. Let me get a little more contrast there. And the light pipe's just going in there when it sees the LEDs turn on and off, and it's just activating the drone. So I can just demonstrate that real quick. with the controller here. So all I'm doing is mapping the LEDs to turn on and off. And all you can do that, it's this controller right there to activate the LED lights. That activates the drone. You can see there the LEDs turning on and on.
You want to rotate it so you
It's
can
a
see?
cool little hack, so we don't have to use an additional radio controller on there.
Yeah.
Originally, we were thinking of using something like a LoRa or something like that to enable that to work, but super happy that this was able to be all one contained little unit. And we actually have a little latch claw hooked up to that. You can actually go ahead and change that around. All of the files, of course, are all in Fusion 360, so you can adjust the teeth or the design for the actual arm, which for this purposes in the video, we used it just to carry around like a little mesh bag. So if you open that up, close that in, and that works very well. The maximum payload capacity for the DJI Mavic is about 2 pounds or 990 grams. You let go of that, you can drop that. So one of the cool things you can use this for is in research sites, like say you're on lava. There's a lot of crazy lava stuff going on in Hawaii right now.
Yeah.
You take samples because you don't want to like risk going over beaches or anything like that. You could actually just fly this over, deliver samples. A lot of people in the comments for the YouTube video were actually saying this would be really good for ham radio, where you can get longer wires up into inaccessible spots. One of the cool things, like in remote places, you can like string wire to like create a bridge across 2 different areas. So there's a lot of really cool projects you can do in terms of research, education. The follow-up to this project is actually going to be the classic egg drop test. So we're going to have Carter's actually working on this, where you have velocity data from the CircuitPlayground, and as it drops, it'll test whether a enclosure you designed was able to protect your digital egg or not. So lots of cool uses for that. And let me go ahead and turn this off. One of the cool things about this too is it maintains its portability because the Mavic is able to fold up into a nice little compact little drone here. You can actually fold everything up like that. Move the wires out of the way here. And everything's able to be a nice little compact little unit without actually kinking any of the wires. There is enough clearance to actually thread all these through when you fold up the arms. And this is actually how we were running around getting all those beach shots for the video. Very nice that everything can stay all assembled without having to disassemble anything. Super useful for taking out on the on research sites or on location. Of course, we have a whole guide set up for this. You can check it out at learn.adafruit.com. Have the entire step-by-step assembly of this. Have a nice little list of all of the components listed to use in this project. Scroll down a little bit. There's quite a bit of 3D printing that is required for this. And of course, a lot of screws and components to put this together. But it's pretty easy if you just follow the step-by-step tutorial on this. It's a nice little way, which I was really surprised when you look on like Thingiverse for like claws. There are a ton of them out there, but none of them actually tell you how to assemble it or how to put it together. So this should be a little bit more inspirational in terms of being able to set one up for yourself.
Cool.
Going into the circuit diagram, super easy circuit. There's no soldering required in this. We're actually using the M3 screws and nuts to actually hold all of the cables for the servo. We're just using the M3 nuts to act as a nice holder for that, and as nice electrical connection for that. Super easy, just 3 wires for the metal high torque servo that we're using on this. And not too much there. Oh, also a list of all of the screws, lengths, and actually the wire lengths that is required for this.
Yeah, it's very handy. You'll want to get some male jumper wire extensions.
Male jumper wires is what's making this a lot easy to, if you ever do need to completely disassemble, say if you're taking it on a flight and you need to make sure everything's nice and compact, you can use the jumper cables to disconnect all of the main components. Moving on to the code, this would not have been possible without using MakeCode, because I was able to quickly stumble through having the light sensor activate the servo claw for this.
Huge shout out to Microsoft for coming up with MakeCode. It's a drag and drop language that makes it really easy for beginner programmers to kind of pick around different blocks, functions, and come up with different little inputs and little projects.
Yeah.
So it's very visual. It's all modifiable. So we have it over here, which you can kind of see. And you can edit it right here using that button, and it brings you into the little UI. We're using this right here is sort of the regular version. We link to this guy over here. So if you want to start playing with the beta version of the WebUSB, this only works with Chrome because it's the only one that's doing WebUSB. So this connects to your CircuitPlayground device, and then you can download it directly to it. My computer's not set up for it, so we won't do that as a live demo, but it definitely works really well. We have it set up on all of our other machines, except this one.
Yeah, we're going to back up and actually talk about why this is a big deal. You're able to plug in your CircuitPlayground Express through a web browser with code. You're able to write to your CircuitPlayground Express by clicking on the download button. It'll send it directly to there. You don't have to like drag and drop a folder or a file into the bootloader for that. It'll handle all that.
There's no profiles or anything that you need to do.
After you've paired it up, it's super easy and fast for iteration on the exact movements that you want to that I wanted to do for the claw. So this is what made it super fast for it to even come out this quickly without.
And what if I don't have a CircuitPlayground, Pedro? Well, I'm clicking on this button.
Nice little simulator here.
Why is this button not doing anything? No, it's because you can.
There's no server.
Yeah, there's no server connected to it, but you can do certain things like playing with the light sensor by hitting this little doohickey.
Yeah.
You can shake it by hitting the shake button, or is it reload? It's one of the things. Anyway, it's a really cool little simulator as well. If you don't have the hardware, you can still experiment with stuff. And this is really nicely categorized. So if you wanted to play with just the NeoPixel stuff, you can see you can do all sorts of different things like showing animation, setting pixels to different colors, graphing different things, setting the brightness. A plethora of very fun, easy to use, plug and play type functions. Same thing with the NeoPixels. It's a little bit more advanced here if you're doing strips. If you're doing inputs, like let's say we want on button A, we want the servo to work. That's basically what's going on here.
Yeah.
If you didn't want to use the light sensor, you could just swatch. You can just take this piece here and put it right there.
Right to it.
And you can do Control Z's. It's really, really nice. Let's say I don't want this, and just drag it over there. We have some guides that talk about how to use MakeCode in more depth. We're due for a video about MakeCode as we tried searching for linking. It's kind of examples for it. We haven't done one in a while, so it's definitely check it out. It definitely made this project possible, and it'll make a whole bunch of other projects possible too. If you're an educator, if you're a teacher, or somebody that wants to teach this type of stuff,
definitely the way to go. Yeah.
You definitely should check it out.
Yeah, they just recently added Lego Mindstorms to this.
Lego Mindstorm, Microbit as well, Minecraft, because Microsoft owns Minecraft. There's a lot of different things you can do with MakeCode, so check it out.
Again, want to sort of highlight this because I'm not a coder. I wouldn't have been able to actually put this together if it wasn't for
MakeCode.
Being able to drag and drop code around and actually see in real time what my changes were actually doing to the hardware. So definitely check that out. Check out the Learn Guide on how to use the WebUSB, because I think that's a huge deal. We'll probably end up doing a video when that is out of beta, because I think that is the most one of the most exciting things about this.
Yeah, it makes it so much easier to kind of get going, especially since you don't have to install software on like 30 computers when you're an educator or you're trying to teach in a workshop or something.
So work right on a Chromebook. Yeah. Super exciting times for being able to program things like this.
It's great. So
there's going to be a lot more projects that are going to be utilizing this in the future.
Absolutely. So if you want to play around with the WebUSB, we got the link here for getting the beta bootloader for your CircuitPlayground Express. You literally just download the UF2 file, drop it into your CPy folder, because once you plug in the CircuitPlayground into your computer, it just shows up like a USB drive. Drop in that file, and it automatically sets it up for you. It's pretty awesome.
Yeah, and then there's going to be one more drag and drop thing when you download the MakeCode from Microsoft that they give you. There'll be another custom UF2 bootloader. You'll drag that in, and then after that, it'll just automatically work with it once it's paired.
Yeah, I mean, hopefully this one will, I think, make it should work, so you don't have to do that. But yeah, you got two different ways to do it. So we talk about here, and then of course how to actually map the LEDs on the controller. Is it buried in the DJI Go app settings?
It could be if you don't know where you're looking. So the reason that we chose the DJI Mavic is because I think it's the only one that actually allows you to map the LEDs turning
out of the box. Right.
Out of the box. There's no modifications. You don't need like a SDK or any custom software to actually make this work.
Okay.
The DJI Mavics, you can do a lot of
Android and iOS is
it works with everything.
the things.
Also, the Mavic is, if you do some YouTube searches on there, it's pretty rugged. It's made out of some really good magnesium alloys.
Yeah.
There's a lot of torture tests. You know, they're flying it through rain, crashing it into trees, and it still survives. Gavin stuck a stick while it was flying in the air, and you know, it came down a little bit and then went right back up with no damage to the propellers. Quite recently, at the hardware or the big box stores like Costco or BJ's, Sam's Club, these are $400 now.
Yeah.
These used to cost $1,200.
Really?
These are $400 now.
Dang.
For what you're able to get. You're able to get that lift, the durability out of this, the battery life.
It's probably not the deluxe where you get like, you know, 8 batteries and all this stuff.
One battery lasts
what you need, yeah.
like 20 minutes plus.
15 minutes?
No, it's 20, about 27 minutes.
See, I read the YouTube comments. Someone said 15 minutes.
You can do...
Let me correct you. It's 20
there's this
minutes.
thing called
like,
Google search or YouTube. You know, you can look for all the videos of all the torture tests on there.
It did feel like a while. Yeah. We were out there for a little bit.
We were out there for about 40 minutes. We went through 2 batteries.
Oh.
And this is not killing the battery. This is going to 40% of the battery.
Oh, cool.
So
yeah, there's also, and if you're a software developer, there is an SDK for the Mavic Pro, as Yanni is pointing out. So yeah.
Yeah,
and David Smith didn't know that the price dropped down. I didn't know the price dropped down that much. I'm not really into drones.
Yeah.
But it's nice that we have it. We mainly got it for kind of shooting and that sort of stuff.
Yeah, because of the 3-axis.
It's basically a camera that flies.
Yeah, it's a 3-axis stabilizer.
Cameras.
This was actually our first 4K camera.
Yeah. It's pretty cool.
So yeah, definitely check it out. There's probably even better deals now, since when I saw this was about a month ago.
Yeah, or maybe you can get it on eBay. Maybe somebody wants to sell theirs because they want the new one.
Oh, the Mavic Air.
Sure.
Yeah.
So we've been wanting to do this for a little bit now, and it's nice that we've been able to do this. All these things had to come together in order for us to do this.
The code, the CircuitPlayground Express, the pricing for this. There's a lot of things that came together to make this happen.
And just the initial push for like doing more robotics and just playing with servos.
Yeah.
So that was a lot of fun. There's a little background story there.
Again, actually, I'll talk about it as we move on to assembly of
let's do it.
All the components. Oh, actually, 3D printing.
Yeah, so 3D printing this was sort of fun.
There was a lot of work that actually had to go into making the enclosure light proof. So if anything that you can take away from this project is you now have a enclosure that you can use for light sensitive. I don't think it's weatherproof, but for any light splash proof, it's definitely splash proof.
It's got Ninja Flex plugs for the ports. Yanni, you totally would like that, man. We got these Ninja Flex ports. We finally did it. It took a long time
to shake the camera. Yeah, so if you're working on a light sensitive project that you want to use with like light tubes or something like that, and you don't want to have any obstructing light or ambient light that'll disturb your readings, you definitely take this case and modify it to whatever you want. There's not that much modifying that you have to do, since the only thing that you would have to edit out would be the mounting holes that are connecting to the legs on there. But other than that, it's good to go for using in any project that would require a light sensor, and you want to pinpoint that, and you want to activate it with a light.
It's pretty cool.
Definitely a great way to add motion without having to add another remote controller onto it.
Yeah. And the way it's designed is definitely designed around sort of necessity, because as we were flying it around using our normal snap fit case design, light was still leaking. You would rotate it in the air directly to the sun, and the server would open.
That's another one I want to point out too. This works in bright direct sunlight. Florida direct sunlight. So
on a clear day, no clouds in the sky.
Yeah. So this works in all types of lighting conditions. Works very well for that. I made sure that the thickness of this didn't let any light in. The thing that you have to watch out for, and I have it in nice red bar there as a warning, it has to be black filament. I did try this exact same enclosure, no modifications, just a different pigment color. I tried it with a red one, and the light leaked right through, even with a 3mm thickness for all the walls. It still went through there. So you want to make sure that you're using black filament for the enclosure.
For all the parts of the case.
Actually, the clip as well. that is holding on to the LED clip, because as you'll see a little bit later, there is a hood on it, so no additional light can actually leak through that part. Yeah. So there were a couple of areas I had to make sure that light wasn't able to actually get into it.
So let's talk about support material. Doing these type of geometries was like, you didn't want to limit yourself to having to break those pieces apart even more. So it's like, just use supports. We got really good supports now. We have different materials. We have breakaway support material.
I would definitely suggest using a support specific material like the Polymaker's Poly Support, PVA, or in our case we use the Ultimaker breakaway supports. It's able to give you a nice dimensional accuracy without fusing any of those support materials into the walls of your part. We
also have tools now, like in Cura, we have the ability to kind of tell what not to put supports. So you have even more control over your supports now. So it's now, if you
scroll down, I can actually talk more about this.
Did we miss anything up here? Just search general slice settings, of course. You just want to throw that out there. You want to change your line width and your layer height. That looks all the same to me. Retraction count is down to 10. So take a look at those if you really want to dive deep into the layers. But let's talk a little bit about the support material and how to apply them using Cura 3.1.
3.1, yeah. If you want to go to the preview section of this, just so you can see the GIF animation of this.
Right down here.
Yeah, so I'll show you where the support blocker for this is. It's right on the left corner of the bottom icon there. And you can just place these over the parts where you don't want any supports being calculated. In our case, it was these 45-degree angled tabs that fit inside of the smaller feet of the Mavic. We didn't need any supports there. For whatever reason, Cura likes to calculate those, even though I had my support angle set for calculating everything at over 60 degree angle, but it still wanted to calculate it there. So in those instances, you can just tell it, hey, block support for this area. And it'll happily discard any supports.
You probably want to play around with the UI just to get an idea of how it works.
Actually, it's a lot more stable in 3.1.
I haven't yet to play with it, so I'm all into it.
Yeah. So definitely recommended for whatever project that you're utilizing that needs supports.
Yeah, we need more control over supports, so this is
the next best way, I believe. Yeah. Move on to the kind of long assembly. Oh, the bottom of the cover case for this, because of the way that I had to sort of make like a hood around the ports for the JST and the USB. I couldn't make a completely flat cover for this, so there are parts that protrude. So unfortunately, you are going to have to use supports for the entire bottom of the case for this.
Yeah, like we were saying, just these type of geometries, it's nice to be able to make them now without having to worry about splicing it into like 100 different pieces. It's kind of nice.
And then the last part, the port covers are actually printed in NinjaFlex, simply because of the way that the covers need to curve around the cylindrical shape of the enclosure. The reset button too, we have access to that. You don't need to necessarily print this in NinjaFlex, but since it was already loaded, I printed that.
I think you should as well, because you kind of need to kind of tuck in to those sidewalls, right?
Yeah, so I mean it does hold it in there pretty well.
That's the best part about NinjaFlex. It kind of molds around whatever shape you're trying to do. So that works well.
You could also modify the shapes to be
So this was actually printed
pretty
with
curved.
Just, the actual Cheetah, not NinjaFlex regular, because the Ultimakers that we have here, the 2.85 filament works best with the Cheetah filament.
Okay, moving on to assembly. As we stated before, you don't have to necessarily solder any of these connections. We're just using the M3 screws with nuts to hold in each of the servo connections. We're using jumper cables though, so we can easily connect those if we ever need to change out the battery, because unfortunately for that you are going to have to disassemble the enclosure to replace the battery. There isn't a charging circuit on the CircuitPlayground Express. So that is one of the little smaller inconveniences of that. But we do have a 500 milliamp hour battery that should last about all day if it's just plugged in and periodically activating the servo. It should last about a day. Should be good for that.
We haven't had to recharge ours yet, which is nice.
I think I've recharged it like 2 times.
Oh, okay.
Okay, moving on to assembling everything into the enclosure. The battery lays on the inside of the enclosure. There's a little port opening there for the JST wires to come out of. And the standoffs are big enough to prevent the CircuitPlayground Express, which lays on top, from sort of squishing the battery. So there is ample room in there for wires. You can actually tuck more wires on the inside of there to free up some of the slack. So there is room for the battery.
So you didn't have to shorten the battery cable? That's nice.
What's that?
You didn't have to shorten the battery cable?
No.
That's always a nice thing.
Yeah. So you can actually just tuck the extra wire slack into this area. And because it is on the back of the board, it is covered and no light will leak through there.
Sweet. All right.
The cover is going to be attached to the leg of the Mavic. So it's on the left leg of that. Both parts are actually identical, but they're just mirrored. So just look at the Mavic legs have like a triangular shape. So just look at the matching those up with the proper leg. And of course they are labeled there too. So we're just using M2 5 millimeter long screws to attach that to the leg. There are already mounting holes modeled into the leg. You just want to make sure that you pre-drill those so you can create the threads for that. You could also tap them, of course. And then we'll insert our reset button extension into the enclosure before closing the cover and the enclosure together. Scroll down. You want to align the port openings. The bigger port opening is going to be for the USB cable port, just so that you have enough clearance for hooking up one of those, the fattest USB cables that we have. So those should have enough clearance for that. And then we're just using the M3 12 millimeter long screws to hold both of the cases.
Clamp shut.
Actually, this is actually wrong. Actually, it's M3 by 16 millimeter long screws. So I'll go ahead and edit that. Yeah, I have the parts list. Yeah, I have the parts listed right.
But in the guide,
here. Yeah, it's actually 16 millimeters long. There it is.
Hey, look, we're editing live. Because it's a live show, that's what we do. We do the guide live too.
Yeah, 12 millimeter will not reach because of the longer standoffs. Yeah. You're
like, I tried 12 and it didn't work. Thumbs down. All right, cool. Onto the leg claw.
So once those are connected, we can move on to assembling the leg claw, which is on the back of the drone. So to hold the left claw of this, we're going to use either a lock nut or a threaded insert to prevent the screw from unthreading itself every time the servos activate. So we'll, that fits into the little slot that is in the groove.
It just press fits?
It just press fits.
You don't have to heat it up with a soldering iron?
No.
That's cool.
And it's it is in the shape of a hex nut, so you can either use the hex nut or the threaded insert. Really won't need that. So you can just use a plier to hold that while you are fastening the M3 by 6 millimeter long screw into the insert for that. The right claw is what is going to be attached to the servo. I'm sorry, is that right? The right claw, the right claw is going to be attached to the servo horn, which just press fits into the top groove area of that. And there's nice little stoppers on here so it doesn't move out of the way.
Yeah.
And that is inserted into the gear of the servo.
A nice metal gear.
Metal gear servo,
it's a Metal Gear Solid.
And then before you actually mount this, you want to hook this up to the CircuitPlayground Express and test so that your open and closed positions are at the right angles for this.
Yeah, it's pretty important. You do want to kind of play around and do back and forth testing, make sure your servo horn's in the right spot. Yeah,
you also want to listen to the motor to make sure that it isn't trying to close more than it should. Like it's not running into, like two claws aren't running into each other.
If it's under stress, it'll let you know by like squealing.
You'll hear a nice high-pitched squealing, yeah. So make sure that there are no audible stress happening to the servo. Make sure that your angles are set up properly, or that your gear teeth.
Maximum and minimum are okay.
Yeah, make sure your gear teeth too are aligned, so they're one's not more to the left than the other one.
It can get out of alignment.
You can get out of alignment with the gear teeth. Cool. And then prepping the light pipe, which is in our case we used the PETT from Tallman, which is the other name for this is called T-glaze.
Yeah, you've probably heard of this, T-glaze.
And we used it on a couple of projects before. The last time I think was for a previous Time-lapse Tuesday, where we used it on Alex Hatch's design of the Nintendo Switch Joy-Cons
grips. Yeah.
Yeah. So he was using a light pipe to pipe
the light from the Joy-Con onto the front of the grip, so you can see the connection status through the grip. It was very clever.
A really nice use of getting a light.
Like I said, using a lot of things had to come together in order for this to work. Like
you could usually use like fiber optic strand, but this is what we had. I think it's on like Amazon. I think actually there is some tutorials on the Adafruit Learning System. I think Aaron St. Blaine actually did some fiber optics with the CircuitPlayground Express.
That's right.
Piping the LEDs that are on there over to like a costume.
Very cool.
So again, we're using a 130 millimeter long 1.75 PET filament for that. To make sure that there isn't any light leaks coming in from the sides of the filament, you're going to want to either paint it, or like we did, we just turned a heat shrink tube into sheathing so that there's no light that can get in there. You actually want to use a smaller diameter than what I took a picture of here.
Sure.
The one that I'm using is...
It says that on there?
Yeah, and this is included in the pack that I link in there. It's the 02.0 by 1.0 diameter heat shrink tube. And if you jump over the overhead, you can see
want me to type that in the guide?
How much. It's in the parts list in the overview page. But yeah, it looks a lot more cleaner with having the smaller diameter one in there. And as you can see, it has a little bit of give to be able to insert into the openings for the clip and on the little port opening for the CircuitPlayground Express.
Excellent.
Jumping on over to, once you have both of the leg components finished, you can go ahead into installing these. Started off with the back leg collide here. The two little supports, beams that extend out from the leg. There's two little tabs on there, and those you can squeeze those and insert those into the little slots that are on the smaller feet on the Mavic Pro.
I'm going to switch here to the preview so you can see a GIF, because it shows you. Some of the GIFs don't work when we're editing mode, so we've got to switch it. All right.
Yeah, so a lot of work went into creating the tapers to have enough strength in there, so you can apply quite a bit of force before it breaks on there. So I made it thick enough for that. Okay. So you can squeeze those, get those tabs into there, and those hold it in place.
It goes right in between that sensor.
Yeah, that's one thing I forgot to mention. Yeah, you don't have to turn off any of the vision positioning sensors or the
optical avoidance.
Optical avoidance, which is the sonic sensors on the bottom there. There's two cameras and two sensors on the bottom there, and they are both unobstructed from that.
Yeah, sweet.
Moving on to installing the claw. The front legs for these. I attached mine to the left leg, but it could also work on the right. It's just the way that you're threading your wires, and those snap fit, or press fit right into the leg. Just want to make sure that you remove any retractions that are around left over from 3D printing, as this could prevent the feet from fully seating, so just look out for that. And then the wires are held up against the body of the Mavic with this nice little wire clip, and you can see there in the GIF how to actually attach this from the top. And that's just all it's going to do is just hold the wire up against the body to keep it away from the propellers and the sensors. And if you scroll down there, just showing how to actually thread those wires so you have not so much slack left over, just dangling when you're flying. And then hooking up the clip for this just snaps right onto the LED housing that's right on the propeller mount. Snaps in. You want to make sure that it is away from the rotation of the motor. So you just want to make sure that when you install this, you just want to check that the motor rotates freely. You don't want to get this, because you can get this like that, to where it can get in the way of the motor. So just make sure when you mount this to have this pushed all the way down. The little hood right here should go go up against where the LED is so that it acts as a cover from the sun, so there's no light that can get in through there. So just watch out for that. And then moving on, after that is assembly. You can just connect the PET filament to that.
It says snug fit. Do you need glue?
No, you do want to, before you, I say it earlier in the guide, when you're setting up the clip, just make sure that the filament does indeed fit through there. I did make it a little bit tight, so you want to actually use like a needle or something to poke through it. Okay. Because if you try to use if you try to force the filament through there, you could bend it, and that will obstruct the optical properties of it. If you have like a bend in your filament, it can scatter the light, and it won't get all the light into your sensor. So if you have any problems with that, make sure that your filament hasn't been bent. Okay. And moving on to installing the port covers, they just slide in. There's 2 little slots on the sides, little grooves that allow you to just simply slide it into place, and it should have enough press fit tolerance to hold it in place while you're flying around. Same thing with the JST. There's a nice little slit that you can
insert the power cable. Insert
the JST connection. Plug it in first, and then insert the NinjaFlex little cover for that. After that, you want to do a flight checklist. Make sure wires out of the way, my battery's all nicely fully charged and all that, and do a nice little flight test to make sure everything works, that your gears are in the proper alignment, and then you can try flying around.
Yeah, there's some room for kind of adding on to the project, maybe put an on-off switch or something.
Yeah, that would be nice.
Disconnect the battery, but it just simplifies the build this way.
Yeah.
Yeah, there's a lot of other things you can do with it, adapting the design for something else, like a robot that walks or something.
Yeah, go over the overhead. Cool. Again, if there's anything you take away from this is the case that you can use on any light-sensitive projects. And if you just want drone feet, you can do that as well. You won't have to print any of those. This works just fine as just leg extensions for Mavic Pro.
5 different projects come into one.
Yeah.
Very cool. All right,
so
check out the guide on the
flying claw. Lots of really cool uses for this. If you guys build one, don't forget to tag us in the Thingiverse page for I made one or you imagine. Our pin shape, they're up there as well. Sweet. The Fusion 360 files are all nice and available as well, so you can modify the clone or the claw for this, and make the legs bigger.
Yeah, be sure to check out MakeCode. It's pretty fun.
Yes.
Yeah, and CircuitPlayground. Sweet. So if you want to pick up CircuitPlayground, microservos, any of that stuff, light pipe, that's the coupon code today. It's good until 11:59 p.m. Only works with everything except gift cards and subscriptions.
That's right.
Pretty good deal. Sweet.
Moving on to this week's, what are we prototyping?
Yeah, sure. So yeah, this week, what are we prototyping? Well, I'm still working on some boxes. Yay!
It is still
crazy box season. So wanted to come up. Last week I showed you guys a box. This week, thank you. This week I came up with a one-piece foldable box that's made out of chipboard. So this is not cardboard, it's actually chipboard. It's like it's a thick paper that you might see in the backing of like photos and things. Let me see if I can do some fancy camera work here. There we go. So yeah, so this is a box. I got a CircuitPlayground mounted to the top here. I also have a microservo mounted to the side of the box. It's just a box, but special thing about it, if I open it, there's the wires and there's the battery. Woo! Fits perfectly. All my components fit perfectly in here. There's a little hole here. Hole allows these wires to come through, and everything kind of plugs in here. There's no soldering here. It's just alligator clips. We have these really nice alligator clips that have male male jumper cables that are just disconnected unknowingly. And the cool thing about this box is that it is designed in Fusion 360. It's completely parametric, so we can come into the Fusion 360 and change the dimensions as we see it. I'm just trying to close it nicely so none of the wires are kinked. And just coming up with different box designs is kind of interesting. So there's a little bit of an insert tab here that kind of gets slotted into this hole, and that's what kind of keeps it shut. So what does it do? It's just a little box that holds the CircuitPlayground and the micro servo. So we can do kind of things like this. This is Blinka's papercraft that we talked about last week, or maybe the week before. I can't remember. All the weeks are blurring. And it's all running MakeCode. So the NeoPixels are working well with the servo, which is kind of hard to do with C, but it works well. And I also have it when you shake it, it'll go that way, which is kind of neat. All this was put together in MakeCode. Again, the box was designed in Fusion 360. So how did you cut the box out, Noah? That's what Paige is supposed to say. I cut it out with the Cricut machine, which is a vinyl cutter. It can also cut other materials, not just vinyl. It can cut chipboard. So why are we doing this? Well, it is a way to kind of make it more accessible to make project enclosures, to design projects. So thinking about it from like a box design, you can do quite a bit with just paper and chipboard and one of these vinyl cutters. So let's take a look at a little clip of kind of putting this box together and sort of the workflow for it. So the vinyl cutter that I'm using is from Cricut, the company Cricut, or maybe they have a different company, but it's the model name of this. This is the Air 2 Express. We talked about it last week. We got it last week, I want to say. And this one has two heads, so it can do scoring. So you can put a score pen on one of the tool heads and then a cutting knife on the other tool head. And then the chipboard gets secured to the sticky mat, which is just fed into the machine. The file format that the machine likes is any type of image format, preferably vector, so DXF or SVG, which is what Fusion 360 can export. And then because the tool head has a scoring pen, you can assign lines and folding lines to be scored instead of cut, which works really well. So this is just a really quick edit of me putting together this box design. I think it would be a really neat tool for I don't know, classroom settings or maybe even workshops and stuff or maker spaces. One of the benefits of having a vinyl cutter instead of something like a laser cutter is you don't have to worry about ventilation. You don't have to worry about a sort of a high price tag as well. With these laser cutters, it can get pretty pricey. Vinyl cutters cost somewhere around $200 and $300 depending on the size and sort of the tools that you get with it. But for the most part, this works out of the box with the tools that come with, which is pretty neat. So what's cool about this design is, well, it's parametric in Fusion 360, which I could take a look at now. Let's see if this will work here. I'm going to switch this to the screen. We're going to do some tunnel vision. And I'll show you the box design in Fusion 360 because it's kind of neat. I really like to put together, or I'm trying to put together a layer by layer of kind of showing you how to put this together. This was designed using the sheet metal workspace inside of Fusion 360. So you can switch to it right up here. So I got the sheet metal. One of the cool things you can do is you can do a flat pattern. So with this flat pattern, I can activate it, and this basically unfolds my three-dimensional design into a flat 2D design. And what you can do with this is you can export this out as DXF, which contains the vector data, all the paths that a machine like a laser cutter, or in our case, a vinyl cutter, can cut this out of material. So it's very nice. And the vector file also contains the bend lines. In our case, it's fold lines that you can assign in the software for a vinyl cutter, like the Cricut. You can assign these lines to be score lines so that you can fold this a lot easier once it's cut. So it's really, really cool. So you can exit the flat design and keep modifying this design to it. So I have my components here already. The CircuitPlayground mounts on top. There's a little hole here for the battery, and there's also a hole here for the components. I can hide the components here just to kind of show you the box itself. And the cool thing about the sheet metal environment is that it's really easy to kind of create these type of designs. So I've been experimenting with that. There's a little bit of things to look out for, like bend reliefs. So you'll notice here that as this sort of folded tab here tucks into this side wall, you kind of have to accommodate for this width here so that it gets pushed inwards and not on the outside. But these are all things that you can change and modify in each flange. So it's kind of a neat little design. And if I right click on the body, I can do opacity control. Let's make it 50% so we can actually see through the box. And that way you can see all the tabs that are actually tucked and creating sort of the structure that makes it an actual sturdy box. Because if you don't have flaps in the right way, the box won't kind of keep itself together. So learning about box design was kind of interesting. You kind of just take a box and take it apart and see how it's working, and then just kind of recreate it using the sheet metal tools in Fusion 360 made it a lot easier. I did have to kind of learn a little bit, but I think the stuff that I learned, I'll put together a nice layer by layer tutorial, because there are a little bit of quirks you have to account for, especially with these very tucked in flaps and folds. So that was a lot of fun. So we're going to put together a tutorial for that, probably release the file as well for the following week. But for now, this is sort of what we came up with, so this is kind of a nice box. So once you have one box, you can of course design many other boxes. For example, here's a bigger one, trying to see what's the biggest that we can get on a 12 by 12 platform thing. Because with the Cricut vinyl cutter that we have, the max work area is 12 by 12 inches, which is about 300 millimeters. So this is a box Pedro's working on. He worked on this piece right here, which is a compatible Nintendo Labo button. This is a button that has a little springy action, talked about a couple weeks ago. And this is a box that will house the CircuitPlayground and a battery, so that we can have just this big button that you just kind of stomp. And so it's a cardboard stompy button. It'll probably play a sound effect, so we'll also mount a speaker or something right here. This was all cut on the Cricut machine, the vinyl cutter, using that chipboard. This is a 0.8 millimeter thick chipboard. It's pretty accessible. You can get it from like art stores or Amazon, like we did. This is a little bit of a different design. It has these two kind of bunny ears that kind of slot into this. You open this, and then these have slots in there, and this all unfolds. No glue necessary. It's all just one piece. You got some nice drafted angles here that allow the box to kind of close shut like that, which is pretty neat. So we're gonna start making some takeout food box designs. Gavin wrote on that right there, which is kind of fun. A lot of fun little things that you can do with these vinyl cutters.
Yeah, Bill's saying that he has a Cricut. It's great for making custom gaskets.
Gaskets, huh? That's interesting. Out of
which material?
Yeah, what material? You got like
awesome.
a rubber material?
And he was also asking about the how to map the buttons, and you can check out the link for the learning guide on there.
For the Mavic?
For the Mavic, yeah.
Oh, yeah. Mapping the buttons is, it's done through the DJI Go app for Android or iOS. I think this could be a neat little way to kind of showcase how the CircuitPlayground is, because you have complete access to the CircuitPlayground here. You get access to all the sensors, and what I like about it is that I didn't solder anything. It's just these alligator clips that come in here, and quickly connect and switch it around or whatnot, but it keeps it all contained, so like it fits in my hand, just like last week's project, but with less cutting, because I got sort of tired of cutting cardboard, so I was like, let a machine do the job for me. Yeah,
after you cut yourself once with the X-Acto knife, you're like, all right, maybe I don't need to be cutting this.
Yeah. I've had a pretty bad accident with the X-Acto knife. And this is we'll be releasing our papercraft characters within the couple weeks as we.
I actually have a couple that you've already been working on, yeah, and then of course
we just got this in. Just got Cricut, our
beta Cricut in as well. So we're going to be doing some fun projects with that. If you've been keeping an eye out on the social channels, PT has been releasing a lot of really cool projects utilizing all
PT,
the.
You just can't give up with him. He's killing it, man. He's coming out with great projects, great ideas.
Multiple servos and motors, audio and light effects all at the same time. This is right up there with like
all that.
Yeah. This is right up there with quality of like Disney animatronics. So
yeah, it's pretty great.
Super cool. They're able to do really cool, complex projects like that. So a lot more on the horizon.
Yeah, it's
the
cool.
Cricut board being released pretty soon.
Cool. People are saying gaskets are a great idea. Yanni's thinking maybe like small ADA boxes that have special electronics in them.
Exactly.
Yeah, totally. Yeah.
Exactly
What's really great about this is that, unlike 3D printing, we can't just 3D print enclosures and then sell them to you. It's just not logistically makes sense. Something with this, we can crank out a ton of these boxes, because we have a couple laser cutters at the office. We could laser cut these if we wanted to. So will we do that? I don't know. Maybe. That's one of the goals. If anything, we'll be able to release a template so that folks can print them on their own and then cut them out with scissors. That's always fun for the kids. Or cut it out with a vinyl cutter if you have access to one, which is more affordable than a 3D printer. And it's paper, so feel good. It's paper. It's
yeah, what's cool about this is
biodegradable.
you don't even need to use a chipboard. The regular type of paper works pretty well. It's going to be a little bit more flimsy, but you can actually get a feeling for the project.
Yeah, absolutely.
Actually put it together and still be able to have a nice little enclosure that is still actually usable.
Yep.
So super cool.
We're starting to see packages too integrate electronics into them. Thinking about like the Star Wars Speed Racer drone, where the box is this like experience that you open up and there's electronics being triggered as you open it. Very, very cool. Good comment here is like, whoa, 8-About Labo kits incoming.
Yes.
What if you're trying?
Yes.
I mean, that's one of the things that inspired us. This is a straight rip from Labo, but redrawn for the Cricut machine for cutting, because their paths were a little jarring.
Yeah, so we just got also, so we got the Cricut Air Explorer 2, which is what we've been using to cut out all of the
You want to
chipboard.
open this one? The next thing is in there. The next topic we're gonna show. Yeah, so
they're like opening a present. What do you guys think it is?
The tabs at the bottom. There you go.
Ready?
Yeah. So inside the box, you're talking about special electronics. Yeah, maybe we'll do this. So I sent this to Osh Park. This is last week's project, the double-sided PCB for the CircuitPlayground Express. Lets you kind of stick different connections into it a lot easier. Lets you put it on a breadboard. I ordered this from Osh Park maybe 2 or 3 weeks ago. It's about 18 days ago, so it takes a little bit to ship.
Yes.
So just kind of, but you get some really nice quality. Take a look at this. So we want to bring that up as close as you can. Let's see if I can get really close up in there. So I really like playing around with different silk screens, different effects. So using the stop solder mask, you can create these cool things. So on this side, you'll see that the D20 here is actually just the silk screen, the white silk screen. You flip it over, it's actually a solder mask, a solder stop mask, so that the actual purple solder mask is not covering the gold plating there. So you get some nice quality. And then of course you got the happy little base here that's also copper. So it's a lot of fun to kind of play around with those effects, those different layers, and trying to come up with different like little things. And then on the other side you get these like curvy traces. So it's pretty neat. One thing that I did get wrong here, and I didn't know why, but I'm learning how, is that the pads actually aren't through-hole plated. They're not plated. Which is like, oh no. So it's something I have to go back and figure out how to do. Maybe there's a layer or something where you have to specifically say, I want this to be through-hole plated.
Yeah, so to have these connected, you'd actually have to have the solder on the top or the bottom of this.
But luckily, the pin headers on the inside there are through-hole plated, because they're sort of this default object that you can use and reuse inside of the Eagle CAD software. So those are through-hole plated, so those do complete the circuit, and they make the double-sided, so it works out well.
Just for people who don't know what that means, the inside here.
You can show it on this one too, because this one you can see how the CircuitPlayground actually does have those insides are through-hole plated.
That is right.
It's kind of hard to see, but yeah.
There
you go. They are
right on the inside.
Electrical, so that's how they're double-sided. So I need to find out how to do that. So. Obviously I can't do that with the milling machine. Well, maybe not so obvious, but yeah, you can't do through-hole plating with a milling machine. So I wasn't really able to test that. So sometimes you do have to send it out. Well, absolutely you have to send it out to your fab house once you have
to at least
a ready layout, just to see what the effects come out like. What does your stops, your solder mask come out like. Very, very fun. Shout out to the Osh Park team. They're doing great stuff.
SDWNJ is saying very Medusa-like, especially this side.
Yeah, totally. Yeah.
So this will be forthcoming. You can actually download this. You can already order this.
Yeah. Also, Dave Estelle's released his as well.
Oh, yeah.
Which I linked in my guide for this one, and the YouTube video for last week as well. So check that out if you want to.
Yeah, differences in his are the ability to mount it vertically. So just in case you need a little bit more extra room. So definitely check
and
out
he has labels. He has like every pin is labeled nicely, so you know exactly what you're connecting into. So if you're a power user, you really want CircuitPlayground prototyping, definitely pick one up.
We got about 5 minutes left. We can jump into this week's Community Makes. This week's Time-lapse Tuesday is this really cool digital sundial.
That's right. Let me focus. Come on.
Focus. So this does come in a couple different versions depending on what hemisphere you're on. So I did print this to appropriate one.
Oh, really?
And yeah, so there's like a northern and a southern hemisphere one.
Let's go.
And there's a couple of different attachments too, so you can hold this up. In the video, I've just used like a magic arm clamp to hold this over a table so you can see the shadows for this. But it's super cool. Check out the video. I don't think you have it playing. But yeah, the sun goes through here, and depending on the angle of the sun, it has all of these little, I don't know what they're called, like bits that... Digits that in shadow form, the segments that show what time of day it is. Yeah. It takes quite a while to print though, about a day, because you do have to use like 100 mil layer height for this. But you can see here that
100 micron?
100 microns
layer
for
height?
this, yeah.
Holy molies.
But check it out. It does
works.
Just got to make sure you position it in the right spot.
That's right.
This is actually running backwards because I had it on the wrong position.
Right. So really, the position definitely matters.
Yeah.
If you're trying to film it, it makes it a lot harder because you're trying to get into the shot and all that. But anything special about the print other than the layer height being so low?
Yeah, 100 microns. I think it used like 10% infill with the triangular pattern. So it's not heavy. Oh, one of the comments too was like, oh man, did this melt? I had this thing outside all day.
I told you it was going to melt.
Florida sun.
I told
you could see the way that this is held up too. Like it's, you know, like there was a lot of bend areas and none of this stuff bent.
Yeah,
so
pretty cool. I guess because it's the layer height and because it's not 100.
We're using melt ink, PLA.
It's pretty
all of this
day, 85 degrees.
It's probably 90 degrees, yeah. Nothing melted out there. So it just depends on what type of filament, I guess, you're using, or, you know, what. Cheap filament, obviously, they're skimping out on something that's making it melt.
This is melt ink? Yeah.
This is melt ink, yeah.
Cool.
So, yeah.
This
survived. Yeah, this survived just fine. But again, it depends on what material
it's not like ice cream, guys. It's not going to melt. It's not like ice cream. It could melt, I mean.
Oh, yeah.
It will if you're in the car.
It melts when you run it through an extruder. But yeah, super simple build. Just screws, nut.
Right. Very, very cool. Let's take a look at the Thingiverse and then get out of here. Sorry.
Got a bunch of makes this week, and you can check it out here. Shout outs to Mojoptix.
Mojoptix.
A lot of cool designs.
Great design. A lot of people have made this. This is 22,000 likes on it.
Definitely follow him on Twitter as well. Posts a lot of really good like designs and engineering type designs as well.
This is very, very clever.
Some really cool stuff that he has.
Sweet. There. Awesome. Check it out. Make your own if you'd like. All right, real quick, we're going to run through these makes. Lamora posted this. This is a Star Trek comm badge using the CircuitPlayground Express. Very, very cool. You can 3D print it. We CNC milled it out of actual metal, but you can 3D print it as well. This is a planter that Pedro designed a while back here in Maya. This was uploaded. This was the make was posted by Radu on Thingiverse. So thank you, Radu, for sharing this make. It's a really nice little thing. You can also hold tools or whatever. It's Boo. It's from the Super Mario Brothers franchise. Very, very cool. Nintendo, please don't sue us. Zelda Breath of the Wild, another Nintendo thing. This is a really cool one because Brendur is actually a software programmer, so he spiced up the animation. Look at this. This is actually what the animation looks like in the video game. It's super, super cool. He wrote the code in C, I believe, using Arduino. I tried the code, and it was kind of interesting because the colors were a little bit different. But it might work for you, so give it a try if you made one of these awesome swords and you put it on the wall, which is great. Google AIY voice kit, Adabot. This was really great, made by this Thingiverse user, Mjira. Oh man, it's tough name to pronounce. Tough handle. But yeah, printed on the Prusa i3 clone. Very, very cool. Check it out. Google AIY. Solder dispenser, another Adabot themed thing. Very, very cool. Printed on Costal Mini by Sivly Clug. Thank you for posting that. I appreciate it. Another Breath of the Wild build. Man, Pedro's sword gets built so much. It's great. So shout out to you, sir. Widescreen John posted this up. Sweet. He printed the modified version by Straf. So thank you guys again for the community for modifying this design to fit on other printers. PyGirl 2. This looks really cool. This reminds me of vinyl, being able to cut vinyl. You can do these type of details, like these little labels and stuff, especially on this PyGirl. It really makes sense because you can label all the buttons and such. So it's really cool. Shout out to VU Lenza 1000 on Thingiverse for posting their make of the PyGirl. Very awesome, really appreciate it. Sweet. And of course, if you want to see some more cool stuff, check out the Show and Tell channel in the Discord server, Adafruit Discord server. We did it. It's 12 p.m. Woo. Thank you guys so much for joining us today. We're not done yet. Well, we are, but we're going to come back here later today. Let's do the... help me out here. Where's it? Here it is. Sweet. So later tonight, we have the Show and Tell with Lamar and Phil and friends. If you want to come and share your projects, what you're working on, retro tech, any of that stuff is really great. So come on at 7:30 p.m. Eastern Time, Wednesday on YouTube and Facebook and the other places. We'll throw out a link in the Discord, so you got to be in the Discord channel to get that link. And then after that, Lamar and Phil, full hour, Ask Engineer. We'll take a look at the, hopefully, more Cricut stuff and more robots and things that Phil's working on. That's Wednesday, that's tonight at 8 p.m. Tomorrow, don't forget, John Park is on a special time at 2 p.m. Eastern Time. I double checked. So it's actually 2 p.m. It's a special time, so set your calendars accordingly. John Park, tomorrow, 2 p.m.
Also, don't forget to click on that bell icon next to the subscribe button so you get notified every time new videos come out, which are quite frequent now.
Yes.
At least 1 or 2 a day.
Feels like 1 or 2 a day, yeah. And don't forget, guys, your orders support the team, Adafruit, New York and afar. We're not backed by any venture.
We're not owned by anybody.
ABCs. Yeah.
Adafruit is
we're able
fully
to do fun, crazy things
funded.
like paper crafts and paper boxes. Very, very fun. So we appreciate you guys' orders and want to, of course, let you know.
Again, Light Pipe. If you see some new products being released tonight, don't worry, there'll be another coupon code tomorrow on John's show.
That's
so
right.
Please stay tuned for that. And I want to thank everybody for stepping by every week.
Really appreciate it. Yay!
We made it.
We made it. We made
Check out all the videos. Give us thumbs up, likes, and don't forget to subscribe. And don't forget to make a good day.
A great day. Thanks, guys. Bye. We'll see you tonight.
See ya.
Bye. How do I end the show again? Let's do it with this cover.
See you guys.
Bye.